slope of a line, section 3-4. All right, you may have noticed that different lines tilt differently. We'll go back and see those in a second. All right, it's very important in many fields to be able to measure and complete or to compare that tilt or that slope, okay, rate of change. In fact, half of calculus is finding slope, finding the rate of change. Okay, very important thing. It's more complicated than what we do here. Okay, but for example, all right, a wheelchair ramp needs to have a certain rise over a certain run. Okay, if you have a wheelchair ramp that's too steep, then it's kind of pointless, because if I'm trying to go up the wheelchair ramp and it's too steep, my arms got to be really, really fit in order to get up. If I'm trying to go down, then we crash. Okay. Also, same thing on a road. Anybody ever driven up a road that's too steep? Okay. You got to put that car in like 4-wheel drive or something, they're trying to get up it. All right. So this measure of steepness we call the slope. Okay. So over here, they're talking about this slope of this ramp is 1/12. Okay, and this is a grade of 11/100 or 11%. Okay, but notice in both cases we have the y value over the x value. Okay, slope, okay, is the change in y over the change in x. Okay, slope is a fraction. Okay, and it's the ratio of the vertical change, so the change in the y, how far you're going up or down, over the horizontal change, how far you're going left or right. Okay? We usually designate that in math as the letter M. Okay? I think I kind of looked it up one time, and like there's some French word that starts with M that means climbing or slope. That's probably where you come from. All right? So this line right here, okay, I can pick any 2 points. All right, and I can say, all right, from this point, in order to get to that point, I need to go from -7 up to -3, so I had to go up 4. So my vertical change was 4, and I had to go over 2. All right, and you would reduce that. So if you reduce that, 4/2 reduces to what? 2/1. We usually just write it as 2. Okay. We would usually, hey, what's the slope? The slope is 2. All right, but when we're graphing it, we would go ahead and put the 1 under that, because that tells us how do we find the next point? We go up 2 and over 1. So notice here, I could have gone up 2 over 1, and there's another point. All right, in fact, any kind of ratio that breaks down to 2 would give that to me. So if I went up 8, 1, 2, 3, 4, 5, 6, 7, 8, and then what's 8 divided by what gives me 2? 4, and I went over 1, 2, 3, 4. Notice that still gives me a point on the line. Okay, I can go up 16 and over 8. Okay, it's still give me a point on the line as long as that ratio is still a 2-to-1 ratio.
Okay, so what made you start from -7 and start
It
counting up? Start from 6 or 5?
It doesn't matter.
Oh, okay.
Doesn't matter. They just, over here, this is closest to me. They gave me this point. Okay, so I could have started here. So hey, from here, this point 2, 1. If I go up 1, 2, and over 1, notice I have a point on the line. If I went up 2 and over 1, I get to that other point that they listed there. Okay? That's what slope is. All right? We often also say, instead of saying vertical change over horizontal change, might have heard it in the class way back when, rise over run. Okay? Your slope is your rise, so how far should you go up over your run. All right, and then your equation to find slope is right here. Okay? y2 minus y1, so literally the difference between the y's over x2 minus x1, the difference of your x's. All right, so example 1 here. If I want to find the slope containing the point 0, 3, and 2, 5. All right, well, I could graph it and find it that way by actually just counting. Okay, or I can just use the equation. We don't want to break out the graph. Okay, the way I just use the equation is I go ahead and I label my points. The first point I label x1, y1. That's the x from the first point, the y from the first point. And then x2, y2. All right, and it actually does not matter which ones you label 1s and which ones you label 2, as long as you're consistent. Okay, these could have been the 1s and these could be the 2s. Okay. All right. So if I plug this in my equation, the y2 is what? The y2 is 5.
Oh, yeah, 5. 5 minus 3.
Minus the y1, which is 3, over the x2, which is
2 minus 0.
minus 0.
So
Okay, so which one will be 2? So do they cancel out or?
Mm-hmm. So 5 minus 3 is 2. 2 minus 2, 0 is 2.
So that'd be 101. So that'd be.
So I'd say my slope is 1. Or you could say it's a 1 over 1.
Why did you do 5 minus 3? Why did you do that one?
All right, because here's this equation right here.
Okay.
y2 minus the y1 over the x2 minus the x1.
Is that the form every time?
Every time. Every time. You got 2 points, plug into that equation right there. y2 minus y1 over x2 minus x1.
My math lab, if it's just one, are they going to ask us to put it in the fraction form?
I would leave it as if it's just a number, I would just write the number. Okay? When I'm graphing, I think about the 1 underneath there, but if I'm just asking the slope, just put the 1. I don't know if they would take off if we put the 1 underneath, but they're definitely not going to make it. All right, so graphically, I got the point 0, 3, the point 2, 5. All right, I have my line, if I can actually draw it. All right, and notice I had my slope of 1. So notice from this point, if I went up 1 over 1, I'm on the line. If I went up 1 over 1, I'm on the line. I actually had to go up 2 over 2 to get to that point, but the ratio all works out where it's actually just a 1 over 1. All right, try your practice. Plug in that formula. y2 minus y1 notice something you need to memorize there. All right, did we find the slope?
Yes,
What did you get?
-1.
I got -1/2.
Yeah, do.
3 minus 0 is 3. -2 minus 4 is a -6. All right, since the larger number is on the bottom, you're going to have a fraction when you reduce. So -1/2. Okay, because 3 and 6 are both divisible by 3, right? So say again?
Why can't this be -2?
All right, because the -2 would give you a different kind of slope. Okay? So just like a fraction, 3/6, okay? 3, if I divide 3 by 3, 3 divided by 3 gives me 1, and 6 divided by 3 gives me 2, and I keep the numbers in the places where they were.
So why did I use -2
You just had -2 as your answer?
I had -2 plus 1. So if it's a power before I use.
All right, the minus here, in between the two numbers, is part of the equation.
Okay, so that equation
Has
includes the minus
the
sign.
minuses are in there,
Oh, okay.
yes.
Now that makes sense.
Okay. So if this had been a -4, it'd be a minus a negative, which would change. So the minus in the middle is part of the equation. Okay. So if I graph those points, the point 4, 0 would be right here. Point -2, 3 would be right here. I can connect those dots and I have a line.
And that, I don't know why we on that.
So would it be
I guess,
down?
All right. And so depending on, this is what I wanted to also discuss this here. Okay. Now when you did your equation for your slope, the negative was actually what? On the bottom. Okay. Now, if we thought about it like that, 1/-2. Totally fine to think about that. Okay. That means starting at a point, the 1 would tell me to go, that's the rise, right? So 1 would tell me to go up 1. And the -2, instead of going to the right, would tell me to do what? Go to the left 2, and notice there's a point right there. Okay? Now, if you only have one negative, okay, then that negative could actually I could move that negative wherever I want to. Okay? In fact, I kind of tend to like to put the negative up top. All right? If you see the negative on top, now the rise is a -1, so you do what? You go down 1, but the 2 is positive, so you go to the right 2, and look, you still have a point that's on the line.
I know why you don't want to use the word calculator, because it graph for you.
I mean, I could. You still would have to do something here. You can't just put 2 points on the graph line unless you have a certain. I guess I probably can write a program for it. All right. So notice either way, whether the negative's on bottom or it's on top, if you interpret it correctly, okay, a negative on top tells you to go down, a negative on the bottom tells you to go left. Okay. I always like, if you're getting confused, I'd always just put the negative on top. So that way you're always going to the right, it's whether you're going up or down. Okay? But you also might just see the answer as a negative or just right out in front of it. All three of these are equivalent statements. Put the negative on the bottom, putting the negative on top, or putting a negative out front. Okay? Because if you have a negative, that means just one of those is negative, not both. Because if both of them were negative, what's a negative on top and a negative on bottom do? Cancels out, makes it positive. Okay? Now notice the difference between these two problems here. Okay, we did have the difference between this one's slope was a 1. Okay, so it wasn't a fraction, but it was a positive number, right? So notice the way this one slopes. As I'm walking from left to right, this one's doing what? It's going up. Versus your practice problem, the slope was negative and it did what? It went down from left to right. Okay, so if you read from left to right, which if you're in here, probably read English. All right, if you read from left to right like we do in English, in most languages, besides like Hebrew. In Hebrew, you read right and left. In Chinese, down, but they don't even have letters. They just have symbols. Okay? Positive going up or left to right. All right, try these. Try this one. All right. Let's see if you can do this one. Same thing. Using that equation, m is equal to y2, the minus is part of the problem, or the equation, y1, x2, minus x1. Mm-hmm. That's simple.
No, like you do X1, Y2, you do X1, Y1, then X2, Y2. You got it right. You did it. You got it right.
This tells you the relationship.
It should become, there's two. Yeah. I think, because I would see
So that's one. So 7
and it's about to say
All right, so do we set it up like that? 3 minus a negative 4, negative 3 minus 5. And remember our rules for adding and subtracting negative numbers. A minus a negative actually turns into plus. So I get a 7 on top. The negative 3 minus 5, I'm going to keep on going backwards, so it gives me a negative 8. Okay, which does not reduce. So I would write my answer. They might accept that. I'll probably write my answer as a negative 7 over.
Okay.
So I just punched it in and saw mine.
And it should give it to you.
Okay, I got you.
So the point negative 3, 3 is over here. Point 5, negative 4, to the right 5, down 4. All right, and notice to get from one point to the other, I had to go 1, 2, 3, 4, 5, 6, 7 down, and then over 1, 2, 3, 4, 5, 6, 7, 8.
I got you, Professor.
And there's your slope. And so that's actually the only 2 points on this particular coordinate grid that would actually work. Okay? Because notice nowhere else, if you draw that line nicely, nowhere else does it actually cross a point. It's like almost touching there, almost touching there. Okay, but those are the only 2 actual integer value points that I got. The other ones, all the other ones would be fractions. All right, more practice. Do the next one.
How, okay. I got that, but I did mine back. I did 5 minus -5. Then I got 10. And then on the bottom I got 6 on the bottom. Can you be like that or?
The way we interpret slopes, so that especially when we get to equations and stuff, so it all works out, you got to put the y values on top. X is on the bottom. Okay?
I did that. Cause 5.
Where are the 5 values? The 5 are in the what?
Okay.
First
X.
slope. That's the X. That needs to go on the bottom.
Oh. Okay.
The X is on the bottom. Y is on the top. So if I went up 3 over 5, that gets me there, right? If I went up 3 over 5 from there, that gives me the other point that I've graphed.
That's the chicken out.
Yeah, it actually graphed it. Yeah.
Yeah, because I wanted to ask the last time, like at the bottom. You start at the bottom of this?
It started at either point. Okay. I started here. So the 3 told me to go from that point. I'm gonna go up 1, 2, 3. So I had to go up 3. And then from there, I went over 1, 2, 3, 4, 5. They got me there, which wasn't all the way to this point. But if I did it again, up 3, 1, 2, 3, and then over 1, 2, 3, 4, 5, that got me to the other point that I graphed.
Okay. So that's to make sure the slope is
Right.
correct.
You can plot them and then actually just count. So notice, when we originally did it, gave you, what, 6 over 10? So that was going up 6 and over 10, which will get you straight there. But out of that other slope, that 3 over 5, that reduced fraction, you could find a point in between.
Yeah, I'm glad I fixed that.
All right.
I had that.
Y's over X. All right, so it's 7:17 according to the clock up here, so it's 7:37. Come back, we'll finish up the section and tackle 3, 5.